Okay, we're going to start this morning by looking at this CC thing we did yesterday again. We didn't add the second part of it, which is a chart, so we'll do that. I also found how to calculate the correlation. It's actually really easy. It's just this covariance over the standard deviation of the first thing times the standard deviation of the second thing. So we got to do two things. One is we have to get the standard deviation. So the standard deviation is the square root of the variance. We already have the variance, so I will just copy that function. And throw this at the bottom. So I forget where I got this algorithm, but I found it somewhere. So one thing that's interesting is this is not typically the way you would calculate something like this. Typically you'd have like a sum and you would keep adding to it over and over, and then at the end you do some sort of division. Like we do that with the average, right? Can anybody think why this algorithm doesn't do that? Like this is kind of complicated. If we're doing the average, the way you calculate the average is you add up all the numbers in the list and then divide by the number of the numbers. And that gives you the average, right? The mean. So why wouldn't we maybe want to do that? Anybody think why?
So you can calculate them one at a time.
So the issue is that when we are working with floating point numbers, they're inexact. And in particular, the bigger they get, the more inexact they get. And with integers, if they get too big, they fall off. Right? They run out. We go back to the beginning. And so when you have huge lists of numbers, that sum can get very large. Okay? And so this algorithm is designed to address that by doing this sort of inline calculation so that the number never gets too big. So I don't really understand all the reasoning that goes behind this. I just know that sometimes the trivial solution turns out to not work so well. And so sometimes you can find people who have spent years doing this kind of software and look at what they did and say, oh, okay, that's a better way to do this algorithm. Anyway, so we didn't have to invent it, we just copied and pasted it. So that's the variance. So the standard deviation. So remember, what did I say the standard deviation was? Square root of the variance. So how are we going to write this function? What's it going to take?
Variance. Wow, how do you do the square root? Well, it's going to take a variance, which is float 64.
Well, it's probably going to take the vector, or maybe I'll just call it x's, and return a float 64, right? And then here we'll use the variance. So we're going to do something like square root variance, right? Everybody agree with that? That's the square root of the variance. This is in the math library. There's a square root function in there. So that comes with Go, and then this we made here, which I probably copied out of Wikipedia, and that'll give us our standard deviation. Okay. And it's just funny, if you look up standard deviation on Wikipedia, you'll get a lot of text, and you won't get this. And you'll be like, that's all I was looking for. It's not actually that complicated. Okay, so to get the correlation, we have covariance in here somewhere. I thought we had covariance, didn't we? Oh, that's weird. Why wasn't it? That was really weird. Okay, there's covariance. It wasn't there for some reason, but there it is now. So we have that, and we have standard deviation, so we should be able to calculate correlation. So let's create that function. So like covariance, you take in two lists of numbers and you get a single number at the end. And that single number If it's positive, then they're positively correlated. If it's negative, they're negatively correlated. Okay. If it's 0, they're not. There's no relationship between them. So the way we calculate the correlation, according to this site, is the correlation of these two lists of numbers is the covariance divided by the standard deviation of the first list times the standard deviation of the second list. Okay? So sometimes when we do this, even though I'm not a math guy, we still have to remember how I talked about how we have to have this, be comfortable with things we don't know. And so if you worked in a company that made web applications for financial companies, you'd have to sort of you might have to work with some of this, right? And even though maybe you're not a math person, you don't really understand it, you don't really have to understand it, right? Because I can work at this level. This I can translate the code, even if I don't understand what the meaning of these things is, right? Makes sense? In other words, I can implement things that I don't understand. Because my job is to implement them, not to understand them. Because you often work with other people who do understand them. So it's the covariance of x and y divided by the standard deviation of x's times standard deviation of y's. Let's just group those together. Okay? So that's not too bad, right? Any questions so far? Okay. Maybe now we'll get the correlation. So let's change this to correlation. I don't know if this is going to work or not. You need to start this. All right. That's right, because we called it something. What did we call it?
Already made off. Made off.
There we go. That's getting better, I think. Maybe. What if I correlate something to itself? Perfect. That's exactly what I expect to see. Right? 1, meaning perfectly correlated. Because the something to itself should be perfectly correlated. So I expected 1. If I inverted the returns, I'd expect a negative 1. So every time Microsoft went up, if his other stock went down, that would mean they're inversely correlated. Okay? Like you get the mirror image. That's interesting that Apple and Microsoft are not highly correlated. What are 2 stocks that might be highly correlated? I mean, does anybody know any offhand?
Or just let's make some wild guesses.
Target, Walmart.
Yahoo and Google.
Okay. So
Apple's been shooting up and Microsoft's sort of flattened out and been going down,
So I don't remember all those. So you said Walmart and Target. That seems reasonable. So what's Walmart? WMT. There's Walmart and Microsoft. And let's do Target. Why is it so slow? There we go. Target. TGT. Yeah, they're much higher correlated. See that?
Ford, GM.
Ford and GM, yeah, those two probably go hand in hand. F. I think the other one's is GM, so yep. It's benefits of being companies have been around for a long time. Oh no. They must not have returned the same length or whatever. Never did figure out what's going wrong there. I think it just must not be returning all the same data. This is 60, this is 56 or something. So something not right there.
I guess the way to fix that would be to go through and look to see if they have equal dates, and when they don't, throw out those.
Yeah.
Compare each entry.
I once had to work on a project where I spent a lot of time having to deal with that. When you don't have reliable data, there are not good solutions.
I wonder
Because,
why that is. I mean,
I don't know.
it's
there's
not
this
like
thing-
GM was on holiday, and it's not like the stock exchange was on a holiday, and I presume the data's not bad.
I don't know.
I
Maybe
think
it
that-
changed something else.
Yeah, they changed the
They-
reporting period or
Yeah.
something, who knows what.
Right, it may have changed something else.
We can change, let's just change in here the, let's just go back 3 years instead of.
Yeah.
It's interesting that it seems to go very fast, because remember, this is pulling the data off of Yahoo as a CSV file. When you think about the steps involved. Anyway, it does seem to work. So any questions about that? It's nice to know that we came up with something that actually worked. I wonder if there's something we can find that's inversely correlated. So can you think of a company where if it goes up, some other company goes down?
Nokia went down when Apple went up, or BlackBerry went down when Apple went up.
Yeah,
From
BlackBerry.
2007 to now.
What's the name of that company?
Oh, really?
RIM, that's it. Is
Yeah.
it this one?
No. They may have renamed, I think they may have renamed the BlackBerry. If you type it in, it might show you the right stock anywhere.
I
Yeah,
mean, there's
think
a
that might be
BlackBerry.
the MBBRY.
It's just the right.
That's goofy.
Might be Macy's and Walmart.
That'd be more Kmart or
Right, yeah,
Sears.
Walmart does better in an economic downturn, and Macy's does better in an economic upturn.
Right.
Okay,
Luxury goods versus essentials.
M. So M and WMT. Is that what we're saying? Less correlated, but still correlated. Okay, anyway, we could probably find some eventually. Though that is an interesting, I think this is an important thing, is we have these ideas of what we think in terms of finance, and then to actually take the data and plug it in and to see is powerful, right? And it's more than, I just speculate that this is true. It's like, is it true? And you can find out, right? And so if you actually plot their returns on their stocks, it turns out they're not inversely correlated. And that's an interesting thing to know.
So my MBA is in finance,
Oh,
and, yeah, and this is called technical analysis,
yeah.
or empirical analysis, looking at the past. And so that's one way people do stuff to try to predict the future. And then also there's fundamentals, right? So what's it actually at today? But then market performance a lot of times or of a equity doesn't work with either of those. It just, you know,
Yeah.
there's crowd factors. It's
Right.
nuts.
Well, you
It's
forgot,
total like Las Vegas.
you forgot the most useful one, which is dartboard.
Dartboard
The
monkeys.
So I once worked. So I was working at a financial services company that when in 2008 when the whole crash happened, and we were looking at we worked with a company that made ETFs, exchange traded funds, which are they just track an index. So like instead of doing a company, you do something like IVV, which I think is the S&P 500. Okay, and so you can invest in the S&P 500, which is like all 500 companies, and that people do that because they don't want to have to pick a stock for and other reasons. But what we were looking at is there are some ETFs that so the real estate market crashed, and there were ETFs that shorted the real estate market. So they were supposed to be, if the real estate market crashes, this thing will go up. That's what it was supposed to be. That was the point of the exchange traded fund. And it actually went down. And we were like, what? Why did it go down? Like the whole point of investing in this was because you thought the market was going to crash. And the reason it went down is in order to have enough volume in their index, they had all these filler stocks. Okay? And what happened is not only the real estate market crashed, but because it was such a big event, it caused the whole market to crash. So all those filler stocks went down too. Okay? And so that's an example of where your intuition can be wildly off base because of like a systematic event.
Well, that's where the term too big to fail comes from.
Exactly. Incidentally, I thought that it was all like there was no reason why Apple stock went down, and then I thought it would go back up, and it did go back up so, eventually. So sometimes those things they correct themselves. So yeah, it's fun to play around with data. That can help you think better, I guess. I don't know. Or maybe it's just overwhelming, you know, like I just don't think I can do this at all. But it's cool. And not very hard to do if you can get the data. These functions are pretty easy to find how to implement, and then you can do them. So the next part here is to add a chart. We didn't do that, so let's do that.
No, this is really awesome because like when I was in grad school, we do all this stuff in Excel. In Excel, it's not very, you know, to update it, you gotta like copy paste in the new data. Your formulas are right there, so it's not real time, it's not programmatic, it's not fetching it for you.
Yeah. Though incidentally, if you use, this is one place where, you know, Google Drive is usually kind of a crummy version of Excel, but this actually turns out to be one place where it's, if they still have this implemented, you used to be able to get stock data right here. So I don't remember how you do that.
The macros or the formula are just JavaScript. And so you can,
Do you remember the name of the function to get stock ticker? Anyway, there's a way to do it. You can insert data from Google Finance directly into your spreadsheet, and it will be updated dynamically. And it will
That's awesome.
all returned. That's like the one feature they have in Google spreadsheets they don't have in Excel. Okay. So let's make a chart. That should maybe be a little more up our alley. Okay. So I'm going to use a library called Chartjs because I was looking for one in Go and then just didn't find any that were easy. So you guys remember how we did this with high charts?
Yeah.
We included a bit of JavaScript. So if I go look up Chartjs here, it tells me include this Chartjs. So this is like a local file that I would have to download from them. Often you can use CDN, so there's a CDN.js, and they host lots of libraries, so they maybe have Chartjs. Sure enough, they do. So there's Chartjs. And so I can use it from here. And so instead of doing a local Chartjs, I'll just use this link, okay? So I just go over here, copy. And
what's
then
the one we used before is called
high charts.
Did you see the bottom of that, Caleb? You're playing about W3 schools before.
Uh-huh. What about it?
There's a comment on the bottom of it about W3 schools.
Bottom and related tutorials.
Sometimes companies, just a little hint here, if you're looking for a job, sometimes companies will put into their source code of their web page, like a comment or something, some neat little trivia, looking for people who look at view source things. And so
Another place would look more for designers than for programmers, but frequently there's a humans.txt.
yeah.
Robots.txt.
That's good. Okay, so we have our script, and then the next part it says is, it's telling you to use require, but we're not doing that. Okay, so we create a chart. We use a canvas tag. So this is an HTML5 tag that provides you a 2D drawing surface, and on it you can draw shapes and stuff. Canvas is a lot of fun. So incidentally, if you're looking for this project at the end of the week, playing with Canvas might be a fun way to try. You can draw things, whatever. So it's a great thing to use to draw a chart. So what we do is we just plop it inside of our body. I'm looking at the wrong, sorry. We didn't have a template in this one. Sorry about that. I was like, this doesn't look like what we're doing. Okay, so we'll pop it in our body, and then from this other, just copy that. Okay. I'm going to change this to //. So does everybody know what the difference between what this means?
If you have // it'll pick it up from the same secure or non-secure HTTP.
Exactly.
So you won't get pop-up warning for
Yep.
non-secure including content.
Okay, so now we have our canvas, and then it says to do this. So create a new chart, give it a context, and a chart. So the context here is a canvas context. Okay, so we can put at the bottom of our page a script.
and that's where we'll put our JavaScript here. So get element by ID my chart, that matches that, and then get context is a canvas thing, and that gives you the canvas context, and that's what you use to draw on a canvas. You can do things like ctx.fillRect to draw a square or whatever. But we're going to just hand it to this chart, and he'll do our line chart for us. Okay. And then if we look at line chart, so we'll draw a chart that looks something like that maybe. And the way we use it is we say new chart context dot line and give it data and options. So dot line, oops, and then data, and I don't know what options will be, so I'll just put null for now. So we need to fill this data object. Everybody follow me? We need to create that. And this is what it says it looks like. I'm not sure what to put for labels. And this is where having that data of the months might have been useful. But for now.
I think you sucked the data in there, but if you do labels, can you show us iota?
Iota? Okay. Do you guys know what iota is? You actually wouldn't use iota for this.
Well, I mean, if you're pulling the number, if you're pulling the number of the month,
you'd probably do this.
Would work for that?
You'd probably do this. Actually, it has to be a bar. Right? Because I want to be able to get the first month, so I could do months bracket 0, months bracket 1. That's probably how you do it. You wouldn't use a constant, because then you'd have to have a bunch of ifs.
All right.
We're not going to do that. We could draw, I mean, if we wanted to, we could do the labels. We're just going to not have labels. Okay. Data sets, there's one or two data sets, right? There's the first one, which is the first line, and the second one, the second one. So the label here, why does it keep doing that to me? What's the label?
Symbol name, symbol
Yeah.
1, symbol 2.
So that'll be the first symbol, and the second one will be the second symbol. So that'll be the first line, the second line will be labeled according to their symbol. And then we have all these fill colors and stuff. I'm going to leave them blank, just going to guess that they will give us something. If not, we'll add them. And then this data is where we get our data. Okay. So. Okay. So JavaScript can't have a Tron comma. We need to JSON format this data, right?
Because it's JavaScript.
Because we have it as a slice of float 64s. Remember we got that up here? So we have that slice of float 64. We need to convert it into a JSON string, right? How do we do that? Marshall. So we will call this data1 JSON, and I'm going to ignore the error, JSON.Marshall data1, and the same thing for data2. And that should give us our JSON formatted data. So all we have to do is plop it in here. Convert it to a string though, because it's a slice of bytes right now. But otherwise. All right, everybody following? Any questions so far? So we will get our chart, create a line chart, and I think this just draws it. I might be wrong about that. Let's look at their example. They don't seem to do anything.
if you were doing your HTML in a template, would you be able to make the variable in your Go file and then call it in the template like you're doing here?
Yeah, so another advantage of templates is I believe that there's a function. Well, you could create a JSON function. So maybe you make your own function like these are. Remember how we did that for the date formatting? We had our own function to give us that nice 3 minutes ago kind of date format. We could create our own function to give us JSON. It's a JSON dot, and it would give us whatever we gave it as a JSON block. And so, yeah, that would be a lot cleaner to use a template to do this.
Even if you did, you could do, yeah, as long as you knew there were floats, you could do data one dot, quote, dot, quote, comma, although that could be comma for the last one.
Oh, yeah, I mean, it's better to use JSON. So yeah, if we used a template, this would be maybe a little cleaner. We wouldn't have to do this part. We could make a function to do that for us. But I think this may just work, so let's see what happens. I guess we do need those colors after all.
Like
You can still
gray.
see it.
I don't know what that means. So we need those
It's worth it.
colors. So let's just copy what they got here.
Do they have a clear color that makes it more transparent?
I'm not sure. Oh yeah, these are all semi-transparent. See the RGBAs? This is like 20%. This is 100%. So some of these are semi-transparent. Let's see what we get. That's better. Not sure why it's saying undefined. But anyway, we drew a chart.
So what's flat Macy's?
Huh?
What's flat Macy's? Moused over
We
it.
have a label.
That's right.
Maybe we need these labels. Just to see what that does.
That's it.
Oh, okay.
But anyway, we did draw a chart. We could spend a lot of time trying to fix it. Does everyone understand why these are like 0 and over here it like goes
Is
up
that
to?
absolute change
Wait,
that
what?
you broke yesterday?
You're a good man, Paul.
I think we have to get Paul on camera one time. to give it-
Yeah, I think Paul, you should just go right on that. I'm Paul, I'm reading off.
Later in the week, you know I'm good for the camera.
Sorry, we digress.
Yeah,
It's that absolute change.
that's right. So I converted this chart into, I made this chart at 0, and then I took the percent change from here to here, and I made that a number, and so on. And so it makes all the data the same for 2 different stocks. Because, you know, Macy's here is 68, and Walmart will be some wildly different number. Well, I guess they're very similar. Okay, actually, in this case, it wouldn't make that much difference because they're very similar. But sometimes they're wildly different. I'll give you an example. That stock is $200,000 a share. So that'll turn all your charts off.
And it's up $2,000 today.
Yeah, but the percent change is not
Yeah,
very
yeah.
much.
Percent change is the same as the rest of the market.
So,
What is that?
Berkshire Hathaway.
Berkshire Hathaway.
The entry point to get Berkshire Hathaway stock is very high.
It's Warren Buffett's
Warren
company,
Buffett's,
the
Microsoft.
guy from
You could
Oklahoma.
get a the B company. That's a little easier to get into. But I think,
It's called market segmentation right there. They're going from the top tier to the bottom tier.
yeah. So I think Google, did they ever split? I think they eventually split.
Google
didn't
is
they?
Straight up, they have.
Yeah.
For the longest time, they didn't split, and people were really complaining because their stock price had gotten so high. And they were like, it's like $1,000 or whatever. You guys have
got the split, because normally you're trying to see to like under 100 or whatever.
Yeah.
But anyway. You also see the reverse. They get so low that they have to like
Yeah.
buy back shares and all that. Anyway. So the point is that what you care about is the relative percent change, not the particular number. Which wreaks havoc when splits happen, because then the numbers are all wrong. And so you have to, actually in that CSV there was an adjusted close, which should account for that. Any questions about that? So that's how we could build our chart, and we could make it look really pretty and or whatever.
If we weren't using adjusted close, that's also why there's no correlation between Microsoft and Apple, because Apple split a year and a half ago.
Yeah,
Big split.
that could be the issue.
It was like 6-to-1 split or something.
Anyway. Okay.